Okay, so here we're asked to solve this trig equation, and it has just about everything that a trig equation could have. It has an amplitude, it has a period adjustment, it has a phase shift of 45 degrees to the left. Theta, this is your variable, okay, like x, and then it has a vertical shift of +4. And we want to see when all of these things, at what angles does this graph equal to 4? Okay, so in other words, this is kind of like if this were a 0 and that were a 0, then we try to find out where the x-axis intercepts are. But for right now, let's solve this thing for theta. So this is your variable. This is what we want to get by itself. So when we solve these things, we try to do the simple math first. So we'll subtract the 4. That's the simplest thing we got here. Okay, 4 minus 4 is 0. Equals 3 times the sine of 2 times theta minus 45 degrees. Okay, and then the next simple thing would be to divide by the 3 to get rid of the 3 in front of the sine. So 0 divided by 3 is still 0. Sine of 2 times this angle. And now, I know it's tempting to want to get rid of the 2, but that's not what we do. Right now, we want to get rid of the sine. Okay, sine is the next thing to get rid of. And you get rid of sine by using the inverse sine. We inverse operate both sides. Okay, we don't divide by sine, we don't subtract sine, we inverse sine, and that's how we get rid of sines or cosines or tangents or whatever the trig happens to be. You always take the inverse trig function. And now that trig is gone away. So we're closer to getting our variable by itself. Okay, now what you have to understand is this thing is an angle. Right? We only take the trig of an angle. And since all this stuff comes after the trig word, that is your angle. Okay, right now this is not an angle. So we have to turn this into an angle, which is good. We know how to do that. This question tells us at what angle is the sine 0. And if you know your unit circle, hopefully you do, we can figure out that the sine is 0 at 0 degrees. That's one of the places where the sine is 0. So 0 equals 2 of theta minus 45 degrees. And the other place that sine is 0 is at pi, or 180 degrees. Okay, the opposite side of the unit circle. So 180 equals 2 times theta minus 45. Okay, because this was given to us in degrees, this is a degree also, rather than a radian. If it were a radian, like a pi over 4, then all of our answers would also be in radians. But they're in degrees, so we'll work with the degrees. So one thing at a time. Now we divide both sides by 2. 0 equals theta minus 45. And then adding 45 to both sides means we start with an angle of 45 degrees. Okay, and the other one over here, we divide by 2 still. So 90 equals theta minus 45 degrees. And adding 45 to both sides gives me an angle of 135 degrees. So those are your two angles that when we plug them into here and do all that hooey bajooey up there, we would get an answer of 4. Okay, so the trick here is taking the inverse sine and figuring out that there's going to be an angle there. Okay, now this other one says tan squared minus 3, and we want to solve it on this interval from negative pi to pi. So let's first solve this, and then we'll talk about everything else. So we'll add 3 to both sides. We have tan squared of x equals 3, and square rooting to get rid of the square means tan x is positive and negative root 3. So then getting rid of tan by inversing, remember we're going to inverse to get rid of the trig, to get x by itself. we are looking at the angles where the tangent is root 3 and where the tangent is negative root 3. Okay, but from negative pi to pi. Okay, so let's do a little quick little sketch here of tan. Tangent has asymptotes at the pi over 2's, where cosine is 0. Okay, so tan looks like this. Oop, where'd it go? There's tan. Okay, in addition, so here's negative pi over here. Tangent has that side of negative pi, and here's regular pi over there. Tangent has this side. So we're looking for the places where tangent is radical 3. So let's make that right here, root 3. And where tan is negative root 3. Okay, so this part comes from your unit circle. And tangent is positive 3 at the angle of, let's see, probably pi over 3. At pi over 3, yep, the tangent is root 3. And then the tangent is negative root 3, also from your unit circle, which is going to be right here. Tangent is negative root 3 at 2 pi over 3. Okay, those are the two places on your unit circle, both from the top half, from 0 to pi. Okay, these two places where the tangent is positive and negative root 3. Now to get this one, I will subtract pi. Okay, your second answer, pi over 3 minus pi, is negative 2 pi over 3. And if I subtract pi here, because all the points of tangent are pi units away, 2 pi over 3 minus pi is negative pi over 3. So these are the two places where tan is negative root 3, and these are the two places where tan is positive root 3.